Hi guys, it's Miss Treese. Today I'm going to start we're going to start our unit on stoichiometry. So for pretty much every video this unit, and by pretty much I mean all of them, you're going to need a calculator as well as a periodic table. Remember, if you don't have a calculator, you can use the scientific calculator on Desmos. That does work very well as well. All right, so let's hop in. All right, so first off, what is stoichiometry or stoic? Some people also call it stoichiometry. Well, it's derived from Greek words. First one is stoichion, which means element, and then metron, which means measure. So, what is stoichiometry? Well, it's measuring elements, kind of. But really, what's happening in stoichiometry is we are going to convert from one substance to another using conversions. And we are going to start by reviewing a couple of those conversions. All right, so it's been a couple months now since we've talked about these, so we're going to start by jumping in and talking about the mole. All right, remember a mole is just a counting unit in chemistry. It's used to measure a very precise amount of a very precise quantity. So the same way a pair is 2, a dozen is 12, a fortnight is 2 weeks. A mole is equal to 6.02 times 10 to the 23rd. You can use atoms, molecules, ions, formula units are the most common ones that we use there. So 1 mole is 6.02 times 10 to the 23rd. Now, we're not really going to use that conversion very often, but it is important to know what a mole is in order to understand some of our other conversions. All right, now the conversion you're probably going to use most often is molar mass. Now, remember that molar mass is the mass of 1 mole. We learned this last semester. We learned how to calculate molar mass, but you are going to add up all the masses of the elements in the compound and add them all together. And you'll use the periodic table to find the masses. So we're going to start with these first few problems, just calculating their molar mass. So I'm zooming way in so that you can see and I can write nice and clearly. All right, so the first one we have is magnesium chloride. All right, so our elements that we've got made up here are magnesium and chlorine. All right, in my compound, I have 1 magnesium. Then I'm going to grab my periodic table, and I'll find magnesium, and I'll find its mass on there. So there's magnesium on my periodic table, and according to my periodic table, the mass of magnesium is 24.30. Then I have 2 chlorines, and again, going to look at my periodic table. On my periodic table, the mass of chlorine is 35.45. I'm going to add that twice. So I'll just add those together. 1 times 24.30 plus 2 times 35.45. Plug them in your calculator, add them all together, and I got 95.20 grams per mole as my molar mass for that one. Okay, I'm going to do one more with you, then leave you guys to do a practice one. All right, so on this one, I have sodium sulfate. So sodium is Na. There are 2 sodiums, and according to my periodic table, the mass of sodium is 22.99. The next element is sulfur. I have 1 sulfur, and again, according to my periodic table, the mass of sulfur is 32.06. And then finally, last but not least, I have 4 oxygens, and the mass of oxygen is 16. All right, and then I'm going to add all of those together. So 2 times 29, or times 22.99, plus 1 times 32.06, plus 4 times 16. Add them all up together, plug it into your calculator, and I got 142.04 grams per mole. All right, guys, we're going to be using molar mass a lot, so I want you guys to go ahead and practice and solve for the molar mass of calcium phosphate here, just to make sure that you've got it and that you remember it. So go ahead, pause the video, calculate the molar mass, and then come back to check it over. All right, guys, so adding it all together, you should have gotten 310.18 grams per mole. Okay, guys, so just remember that the 2 does carry to both the phosphorus and to the oxygen. So that's why we have 2 phosphoruses and 8 oxygens. Okay, so now we're going to talk through how to solve these stoichiometry problems. All right, so there's really 5 steps. They're very similar to our mole-to-mole problems that we learned about last unit. So let's go through them. Or not last unit, last semester, what I was trying to say. All right, so step 1 of any stoichiometry problem ever, and probably the most important step, is write your balanced chemical equation. Now, it may not be directly stated, it may just be implied in the problem. The other thing is, you don't need to look at if we give you a single replacement reaction, you don't need to look at the rules. You can just assume that every reaction is going to happen if we give it to you in a problem. All right, so you don't have to look at the rules, just assume the reaction is going to happen and write it out. Then what you're going to do is you are going to begin with what is given. I always say take what's given. We always have to give you something in order for you to be able to solve the problem. So what is that given? Pull it out. That's your starting point. It's going to go in the first box of your stoichiometry. When in doubt, moles it out. All right, if you need to, if you're not in moles, get to moles, convert to moles. All right, if you're in moles, you're good to go. But if you're not in moles, get to moles. We do that, really in this unit, we're going to do that by using our molar mass from our periodic table. All right, and then we'll use our mole-to-mole ratio. So our mole-to-mole ratio is kind of similar to the mole-to-mole ratio that we learned about last time, but instead of using our subscripts in this one, we are going to use the coefficients from our balanced chemical equation. And it'll allow us to move from one substance to another in the chemical reaction. So your mole ratio will always look like this. What you have, whatever substance you have on the bottom, and whatever substance you want on the top. All right, and then finally, our last step is convert to what you are looking for. So get to what the problem's asking for. Okay, those are the 5 steps. So now I'm going to actually we're going to look through this problem. It's already worked, and I'm going to go through, where the 5 steps are in each of this problem, and I'm going to use different highlighter colors in order to help us see. All right, so step 1, write a balanced chemical equation. So let's read our problem and see if we can find our balanced chemical equation. So it says how many grams of sodium chloride are formed in a synthesis reaction in which 30 grams of chlorine gas are reacted with excess solid sodium. Okay, so we know we have a synthesis reaction, and our reactants are chlorine and sodium. So based on that, we're able to write our balanced chemical equation of Cl2 plus 2Na yields 2NaCl. All right, so that problem, again, it was not directly stated in our problem, but we were able to figure out what our chemical reaction would be based on what it said in our problem. All right, so step 1, balanced chemical equation. Step 2, take what is given. So in this case, our given is 30 grams of chlorine gas, and I'm going to take that, and that's what I'm going to start with. So 30.0 grams of chlorine gas. Step 3 is get to moles. We're in grams, we're not in moles. So right here, we are using our molar mass. So this is the molar mass of Cl2, and we are using our molar mass to get to moles because 1 mole is equal to the molar mass. So 70.906 is 1 mole of chlorine. All right, then I guess that's step 3. Step 4 is our mole-to-mole ratio. So right here, I have 1 mole of chlorine to 2 moles of NaCl. So these coefficients come from our balanced chemical equation. So our coefficient in front of chlorine is 1, and our coefficient in front of sodium chloride, NaCl, is 2. So for every 1 chlorine, I'm going to make 2 sodium chlorides. So our mole-to-mole ratio is 1 to 2. All right, and then finally, our last step is get to what the problem asks for. So in this case, our problem asks for grams of sodium chloride. So there's our factor right there. So once again, we are using the molar mass to convert to grams, and this would be the molar mass of NaCl. Then you solve, and to solve, you multiply across the top and divide by the product of the bottom. And then always, 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 we have to do sig figs in our answer. All right, so that is how we solve one of these problems. But we are luckily going to start much less complicated than this first one, and we are going to move up to one like this. Okay, so we are going to start with just being in moles and converting from moles of one thing into moles of another thing. All right? All right, so our first one says use coefficients. Our first step we're going to do is mole to mole. It's moles of one thing to moles of another thing. Very easy, just basically going to have to use our mole to mole ratio. So the first thing I want to talk about is how do we get our mole to mole ratio? And guys, you use your coefficients of your balanced chemical equation. So one mole to mole ratio for this one might be for every 4 moles of aluminum, that makes 2 moles of aluminum oxide. And how I would write this is I would actually write it in fraction form. So 4 moles of aluminum to 2 moles of aluminum oxide. So we'll always use the coefficients of our balanced chemical equation in our mole to mole ratios. Hopefully that makes sense. Okay, let's jump into our first problem. All right, so first things first, we need our balanced chemical equation. We also need to identify where we're starting and where we're going. So I'm going to read our problem. I always like to underline my goal circle my goal and underline my given. All right, so it says how many moles of potassium carbonate, K2CO3, are needed to produce 15 moles of carbon dioxide, CO2, in a decomposition reaction. Okay, so I've already circled my unknown. So my unknown is asking me how many moles of potassium carbonate, and I've underlined my given, which is 15 moles of carbon dioxide. We'll know our given because it has a number. All right, let's start solving this problem. So step 1, balanced chemical equation. So I'm going to come down here. I have K2CO3 yields K2O plus CO2. Already balanced because I have 2 potassiums over here, 2 over there, 1 carbon over here, 1 over there, 3 oxygens, and 3 oxygens. So I'm balanced. So all of my coefficients are 1s here. Imaginary. You don't have to write them. I'm just writing them so that we remember. Okay? Now then, after we have our balanced chemical equation, we are going to take what is given. So in this case, I was given 15 moles of CO2. So 15 moles of CO2. Now, is moles of CO2 what I want? No, my problem says I want moles of potassium carbonate. So if no, I'm going to drop it low and drop moles of CO2 down there. All right, and move on to my next step. My next step says to convert to moles. I'm already in moles, so then after that, I'm going to do the mole to mole ratio. All right, so I'm going to look at my coefficients of my chemical equation, and I'm going to convert from what I have to what I want. So I have 1 mole of CO2, and I want to get to moles of potassium carbonate, which is K2CO3. And again, my coefficient for that one is also 1, is 1 mole of potassium carbonate. So for every 1 mole of CO2, it requires 1 mole of potassium carbonate. Then our next step is to convert to what the problem is asking for. It's asking for moles of potassium carbonate. So we're good to go and we're ready to solve. And to solve this one, we will multiply across the top, divide by the product of the bottom. This one's nice and easy because, our numbers are 1. So we will end up with 15 moles of K2CO3. That's our answer. All right, let's do the next one. Okay, this time it doesn't give us our chemical reaction, so we're actually going to have to write it based on our problem. So I am going to kind of underline my reaction as well to help me out. So it says sodium reacts with, so it tells me added together, water to form sodium hydroxide and hydrogen gas. All right, so let's go ahead and start by writing our balanced equation. So I have sodium, which is going to be Na, just by itself, plus water, which is H2O, yields sodium hydroxide. So sodium is Na with a positive 1. Hydroxide is OH negative 1. So we swap, drop, reduce. We get NaOH plus H2. Okay. Since that was my first sentence, I just decided to go ahead and balance my chemical reaction, or write my chemical reaction before starting my problem. All right, so I've written my chemical reaction. Now I'm going to read my problem. So it says, how many moles of hydrogen gas, so I'm looking for moles of hydrogen gas, will form if 0.35 moles of sodium react with excess water. Anytime it says excess water, it's just saying that we have plenty of water. So if it says excess, don't worry about that. It's just saying there's plenty of water, so we don't need to worry about that in our reaction. Okay, let's start with step 1, which is balance our chemical reaction. So I have one sodium. I have one sodium on the left, one on the right, so those are currently balanced. 2 hydrogens on the left, and I have 3 on the right. So since I have 1 over here, I'm going to go ahead and put a 2 in front of this to get that to be an even number, which means I will also need to put a 2 here, right there, and that gives me 4 hydrogens on the right, 4 hydrogens on the left, 2 oxygens, 2 oxygens. So now I just need to balance my sodium by putting a 2 in front of it. All right, so I've balanced my chemical equation now. So now that I've balanced my chemical equation, I'm going to start my problem. Okay, so after we have a balanced chemical equation, we are going to take what's given. So in this case, I've been given 0.35 moles of sodium. All right, so I want to, step 1 is get to moles. I'm already in moles, so I'm good. So then step 2 is mole to mole ratio. So is moles of sodium what I want? No, it's not. So if no, I'm going to drop it low. I don't want moles of sodium. I'm looking for moles of hydrogen gas. And I'm going to do my mole to mole ratio. So for my balanced chemical equation, I have 2 moles of sodium, and that is going to produce 1 mole of hydrogen gas. So I have my mole to mole ratio. Now I need to convert to what the problem's asking for. So my problem is just asking for moles. So I can go ahead and solve. And once again, I will multiply across the top and divide by the bottom. So 0.35 times 1 divided by 2. And when you do that, I believe you get 0.175. However, our answer should only have 2 sig figs because our given has 2 sig figs. So our answer is 0.18 moles of hydrogen. All right, why don't you guys go ahead and try to work this problem on your own, pause the video, and come back to go over it. Okay, guys, so for this one, I started with 5.5 moles of oxygen. I was already in moles, so I did my mole to mole ratio. 1 mole of oxygen is 2 moles of water. That's what I was looking for, was moles of water, so I ended my problem there. Multiplied across the top, divide by the bottom, and I got 11.1 moles of water. These next few problems down here are just practice for you guys over multiple ratios. So definitely work those on your own time, but we are going to move on to the next ones. All right, guys. So we're going to go ahead and move on, and we're going to work these mole to mass problems. Okay, so in mole to mass problems, you are going to use one of the molar masses, because we're going to start in grams or something like that, and the coefficients from our balanced equation to, once again, do our mole to mole ratio. All right, so let's start out with the first problem here. All right, it says an amount of 6 moles of magnesium reacts with excess oxygen. Again, excess oxygen just means we have plenty of oxygen. Don't freak out when you see that. In a synthesis reaction, what mass in grams of oxygen reacted? All right, so we know our problem. We are starting with 6 moles of magnesium. We're ending with grams of oxygen. All right, step 1, balance chemical equation. 1 magnesium on the left, 1 magnesium on the right. It's currently balanced. 2 oxygens on the left, 1 on the right. So I need to put a 2 in front to balance it. And then I also need to put a 2 in front of my magnesium there. All right, now that we're balanced, we're going to start. So we're going to take step 1, we're going to take what's given. So in this case, we were given 6.00 moles of magnesium. Step 2, convert to moles. We're already in moles, so we're good to go. So then step 3 is our mole to mole ratio. All right, do I want moles of magnesium? No, it's not what I'm looking for. I want to be in oxygen. So I'm going to drop it low, and I'm going to drop moles of magnesium down low. I want to be in grams of oxygen or mass of oxygen, but I can't go straight from moles of magnesium to mass of oxygen. So I have to do a mole to mole ratio here. So I'm going to convert to moles of oxygen. Then I'll do my mole ratio. All right, so I have 2 moles of magnesium, again for my balanced chemical equation, for every 1 mole of oxygen. All right, so then step 4, whatever step we're on, is to convert to what the problem is asking for. So in this case, our problem is asking for mass in grams of oxygen. So I want the mass in oxygen. So I don't want moles of oxygen, so I don't want that. So if no, drop it low. I'm going to drop moles of oxygen low. And I want to get to mass. So anytime we want to get to mass, we're going to use our molar mass. We'll use our values from our periodic table, our masses from our periodic tables to get our molar mass. And the mass of oxygen is 16. 2 oxygens, so the molar mass of oxygen would be 32 grams of O2. Grams of O2 is what we want. So now we can multiply across the top. So 6 moles times 1 times 32, and then divide it by the product of the bottom. All right, so go ahead and take a second to plug that into your calculator. So 6 times 1 times 32 divided by 2 times 1. All right, guys, so when I plugged it into my calculator, I got 96.0 grams of oxygen. I had 3 sig figs in my given, 1, 2, 3. So I need 1, 2, 3 in my answer as well. All right, so that's that one. Let's try to do one more together. Okay, so this one says C5H11 reacts with oxygen in a combustion reaction. How many moles of C5H11 must be burned to produce 57.3 grams of water? All right, so first off, first step, we need to write our balanced chemical reaction here. So it's a combustion reaction, so I know my products. I have C5H11 and plus oxygen, so plus O2 yields CO2 plus H2O. Because it's a combustion reaction, it always has those same two products. All right, now I'm going to go ahead and give you guys a minute. Go ahead and pause the video. This one is pretty tricky, but I want you guys to go ahead and attempt to balance this equation. Like I said, it's kind of tricky, but pause the video, try to balance this one, see if you can do it. Okay, like I said, this one is pretty tricky. So coefficient should be 4, 31, 20, and 22. You guys may have never seen coefficients that big, but that is how you balance this equation. Okay, so now let's look at what we're looking for. We want moles of C5H11, and we're starting with 57.35 grams of water. All right, so step one is to take what's given. So we are given 57.35 grams of H2O. Now, grams of water is not what we want, so we're going to go ahead and drop it low. So step one is to take what's given. Step two is convert to moles. So we are not in moles right now. We are in grams, so we do actually have to do this step. So since I'm in grams, I'm going to use my molar mass. So I'm going to add up my masses from my periodic table. Oxygen is 16, and I have 1 oxygen. Hydrogen is 1.01. I have 2 hydrogens. Add that together, and I get that my molar mass of my water is 18.02 grams per mole. So I know that for 18.02 grams, there is 1 mole of water. All right, so now I'm in moles. So step 3 would be mole to mole ratio. So I'm going to go ahead. I don't want moles of water. I want to be in moles of C5H11. So I'm going to drop moles of water low. And I'm going to do my mole to mole ratio based on coefficients of my balanced chemical equation. So it would be 22 moles of water for 4 moles of C5H11. All right, and then convert to what the problem's asking for. Our problem's asking for moles of C5H11. That's what my final units are right there. So I am good to go ahead and solve this problem. So I'm going to multiply across the top and divide by the product of the bottom. And when I did that, I got 0.57864, so on. All right, but my given has 1, 2, 3, 4 sig figs, so my answer should have 4 sig figs, 1, 2, 3, 4. And so my answer will be 0.5786 moles of C5H11. Okay, guys, I want you guys to go ahead and pause the video, work this next problem. When you're done working it, come back so that we can go over it. All right, let's go over it. So, all right, guys, let's go over it. So, let me close that. Let's go over it. So I'm starting with 11.33 grams of chlorine. It's reacting with excess sodium. Again, that just means there's plenty of sodium. And I want to know how many moles of sodium chloride are going to be present or produced. All right, so I'm starting with 11.33 grams of chlorine. And then I converted to moles using my molar mass. Guys, anytime you see grams in a problem, you need to use the molar mass. So I know that 70.9 grams of chlorine is 1 mole of chlorine. And then I did my mole to mole ratio. So from the coefficients of my balanced chemical equation, 1 mole of chlorine is 2 moles of NaCl. That's what we wanted. So we stopped our conversions, multiplied across the top, divided by the bottom, and I got 0.3196. My given had 4 sig figs, so my answer has 4 sig figs. And I'm good to go. All right, guys, once again, this is just a practice section for problems over this mole to mass for you guys to work. The key will be posted on Canvas, so maybe work through a couple. Make sure you're getting this before you move on. All right, but we are going to move on to our last type today, and this is mass to mass. So for this, we have to use both molar masses as well as our mole-to-mole ratio, the coefficients from our chemical equation, to convert between the two substances. All right, let's jump in. All right, so it says, how many grams of carbon dioxide are produced when 60.03 grams of propane burns completely? All right, so I'm looking for grams of CO2, and I'm starting with 60.03 grams of propane. All right, step 1, balance your chemical equation. 3 carbons on the left, so I need 3 on the right. 8 hydrogens, so I need 8 hydrogens. And then 3 times 2 gives me 6, plus 4 gives me 10 oxygens on the right, so I need a 5 on the left to balance it. Okay, so we've balanced our chemical equation, so now we'll start working our problem. So, step 1, take what's given. In this case, we are given 60.03 grams of propane. Guys, propane is one of our organic molecules. Prop is 3, so it's 3 carbons there. So propane is going to be C3H8. All right, so we've taken what's given. Is grams of propane what we want? No, it is not. So if no, drop it low. We are now going to convert to moles. So step 2 is convert to moles. We're not in moles, so we do need to do this. Since we have grams, we're going to use our molar mass to convert. All right, so solve for my molar mass over here. I have 3 carbons. Each carbon weighs 12.01 grams. And I have 8 hydrogens. Each hydrogen weighs 1.01 grams. I'm going to add that all up together, and I got that the molar mass of propane should be 44.11 grams per mole. All right, so I'm going to use that to do my conversion now. So I know that 44.11 grams of propane is 1 mole of propane. And now we're going to do our mole-to-mole ratio. So is moles of propane what I want? No. So if no, drop it low. So moles of propane is dropped low. And what I'm trying to get to, my end goal is carbon dioxide. So my mole-to-mole ratio is going to relate moles of propane to moles of carbon dioxide. So coefficients for my balanced equation is going to be for every 1 mole of propane, it produces 3 moles of carbon dioxide. Okay, and then finally, our last step, convert to what the problem is asking for. Our problem wants grams of carbon dioxide. So once again, it's not moles of carbon dioxide that I want. So since it's not, we're going to drop it low. Moles of CO2. We're trying to get to grams. So once again, we need to solve for our molar mass. So come back over here. We're going to solve for the molar mass of carbon dioxide. So I have 1 carbon, and each carbon weighs 12.01 grams. And I have 2 oxygens. Each oxygen weighs 16 grams. And I'm going to add those together. So 12 plus 32 gives me 12.01 plus 32 gives me 44.01 grams per mole as my molar mass of carbon dioxide. So then we'll use that to convert our last one. So for every 1 mole of CO2, it weighs 44.01 grams of carbon dioxide. All right, grams of carbon dioxide is what we want. So now we can solve. And to solve, we will multiply across the top. So 60.03 times 1 times 3 times 44.01 and divide by the product of the bottom. All right. So Go ahead, take a second, plug that into your calculator. And I got 179.7 grams of CO2. Again, 4 sig figs because we are given had 4 sig figs. All right, guys, I want you guys to go ahead and try to solve this one. So pause the video and try to solve this one, and then restart the video when you're ready to go over it. All right, guys, so step 1 of this problem was to write our balanced chemical equation. So we had hydrogen reacted with nitrogen to produce ammonia. So I just wrote it out. H2 plus N2 yields NH3, and then I balanced it. All right, both hydrogen and nitrogen have 2 next to them because they're part of Brinkelhoff, our 7 diatomic elements. All right, then from there, I started with what's given. So 15 grams of ammonia is what was given in the problem. Ammonia was not what I wanted, so I dropped it low, and I used the molar mass of ammonia to convert to moles. Still didn't want moles of ammonia, so dropped it low and did a mole-to-mole ratio, saying that for every 2 moles of ammonia produced, it required 3 moles of hydrogen. Moles of hydrogen is not what I want, so once again dropped it low. 1 mole of hydrogen is 2.02 grams of hydrogen, then multiply across the top, divide by the product of the bottom, and I ended up with 2.67. 3 sig figs in my answer because I had 3 sig figs in my given. All right, guys, so I want you guys to go ahead and solve this last one. The answer will be on the notes key, but I want you guys to solve it. We'll say you are given 2 givens in this problem, so you need to solve 2 stoichiometry problems. All right, so it's a little trickier, but I think you guys can do it. I think you're going to do great. As always, email me or Mr. Oglesby if you have any questions, and I hope this video was helpful. Good luck, guys. Bye.